Hi. This instructional video is all about scientific notation. Look at number 1. For example, let's say 2.5 times 10 to the third power. As scientific notation, the number must always be 1 or greater. Because we're talking about how big or how small things are. So we don't have negative numbers. Okay? So it's got to be 1 or greater than 1, but it's got to be less than 10. So it could be 1 through 9 basically. There's always a decimal right there. And when we have an exponent with a positive, that 3 is telling you move the decimal 3 spaces to the right. If it's positive, it means move right. So guess what minus exponent means? Yeah, it means to move left if it was negative. So that being said, let's look at the first example. We have 3.92 and we want to move the decimal how many spaces? In which direction? Since it's positive, we want to move it to the right 6 spaces. So from here you go 1, 2, 3, 4, 5, 6, and wherever all the empty spaces are, you're going to put zeros there. So the answer becomes, when you evaluate, 3, 9, 2, 0, 0, 0, 0, and this turns out to be 3,920,000. That's it. So why don't you try number 2? Good. So you said, since the exponent is positive, it means to move right 4 spaces from wherever this is. So 6.28, you go 1, 2, 3, 4. Wherever the empty spaces are, put zeros. So you get 628, 0, 0. And then what we end up with 62,800. Yeah. Okay. Now, let's look at what if the exponent is negative? Well, you already figured that out, didn't you? So let me show you number 3. Then you could try the 4 on your own. Number 3, we have 5.6. This time it means to move left 6 spaces. You might want to make it very legible so you could see all the empty spaces to put the zeros in. So here we got 1, 2, 3, 4, 5, 6. So we go 1, 2, 3, 4, 5 zeros to the left. So we got 0.00000056. That is a small number. We're talking like microscopic, very small. Yeah. Then how about this guy? Did you already do it? So you write that real number, 3.762, and take that decimal, move it left because it's minus 3 spaces. 1, 2, 3. Neatness, organization skills, very important in this exercise. So we end up with the 2 empty spaces. So we get 0.003762. There it is. Now this section is about writing into a scientific notation. Okay? Writing into a scientific notation. Now that's just a regular number. We have 36,518. Now I know that this one, to be scientific, it must be 3.6518. Okay? Times 10 to some power. Now, if this was a scientific notation, how many spaces do I need to move to the right to go back to where it was? So you say, well, to go back to where it was, I needed to move this 1, 2, 3, 4. 1, 2, 3, 4. You would like your friend to move this number 4 spaces to the right. So right means positive. And that will bring you back to this original number. So the solution becomes 3.6518 times 10 to the 4th. So when your friend takes a look at this scientific notation and you tell him, make that back into the number, you'll get that one. So now, why don't you try that one? Yeah, so you said, I need this to look like 3.754. But the thing is, to make that back to what it was, how many spaces did you have to move? Well, you had to move, if you were here, 1, 2, 3 to the left. From here, 1, 2, 3 to the left. So you want this to write as 10 to the negative 3, because 1, 2, 3 will bring you back to what this was. So there's your answer. Okay? Now, even though the direction says to write in scientific notation, you're thinking, isn't that a scientific notation? Remember, a scientific notation must have just a number in front. One number, not two. So we must have it as 7.82. Okay, somebody tried it and made it into that. Well, first, let's assume this was a correct way that your friend wanted it. So let's do it, make this into a number, a real number. So if you move from here, 78.2, and moved it right 3 spaces, what would that look like? It'll be 1, 2, 3. So it would have been 78,200. But when that friend moved the decimal to a real number, scientific notation, he only moved it 1, 2, 3. When in fact he should have moved 4. Okay? 4. So this needs to be 10 to the 4th power to bring back the original to that one. That was the intent. Okay? So there it is. Then what would that be? Now let's follow the recommendation. If that was to be written as a real number, it would have been 0.256, and what your friend's trying to tell you is to move it twice to the left, 1, 2. So it would have been 0.00256. But to make it into a scientific, your friend should have moved it 1, 2, 3. Okay? So it would be 2.56 times, not 10 to the 2, but it would have been 10 to the 3. So that is the correct scientific notation.